Cast is now starting. All attendees are in listen-only mode.
Okay, well, welcome everyone to this meeting of the virtual IMS user group, and thank you for joining us. I'm Trevor Eddles. I'm CEO of a company called iTechEd Limited. We're a mainframe consultancy, analysis, and technical authoring organization, and we're responsible for the content on the virtual IMS website, and we produce the newsletters as well. And if you've got any colleagues who work with CICS, we also look after the virtual CICS user group. So, first of all then, let me run through the agenda for this meeting. And as usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Kevin Height. He's Senior Technical Staff Member, IMS Architect at IBM. And his talk is called IMS ODB. And a copy of the slides from his presentation will be on our website later today. And by the way, if you missed any of our previous meetings, you can download copies of the presentations from our website and you can listen again to them. There's a link on the resources page. So that's fundy.com/virtual IMS, and then you'll find the resources page there. So following Kevin's presentation and any questions you have for him, we'll move on to the latest IMS news and the latest IMS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for this meeting, and I'm anticipating that it will last for just over an hour. Anyway, as I just said, today's presentation is from Kevin Height. Kevin is a senior technical staff member at IBM, and he's been part of the IMS team since 2006. So Kevin, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control of the meeting over to you. So let me do that now.
All right, thanks. And hey, everybody. Again, my name's Kevin Height. I work at the IMS Development Lab in San Jose, California. And I've been here for, like you said, 12 years now. And I actually looked back through my notes, and I gave a presentation at this user group probably back in 2009, actually giving an intro to IMS Open Database. And today we're actually going to go into a deeper dive, after having gone through, several rollouts at various customers with Open Database. So this kind of give you some feel of what we've gone through and talked about with customers in terms of performance around these Open Database solutions. So with that, let's just have a look at the agenda. First thing, I'll just give a really brief overview just to get everybody on the same page with Open Database. I really hope everybody's at least heard about it thus far, but it's been around since version 11. And so it's kind of mature at this point, and people are really starting to take it up. But really the main point of this presentation is to really bring you through some performance topics around this solution, around accessing IMS database from off-platform, using Open Database and our Java drivers, as well as accessing it from on-platform. And so we'll go through those scenarios and some of the considerations along the way. So like Trevor said, if you've got questions, pop them in the chat, and I'll try and take a breath here and there for him to cut me off and ask those questions. So going into the overview, we've got the IMS Universal Drivers, which ships as part of the Open Database solution. And Open Database really is a combination of the Universal Drivers, being able to communicate with IMS Connect and ODBM to send database requests from distributed platforms. Now those universal drivers, they can run on distributed platforms from Java standalone environments, from various tools like IBM Data Studio, and then also from Java servers like WebSphere, WebSphere Liberty, and so on. But in addition to the distributed access from different platforms, you also have the ability to run those drivers more directly to IMS on platform. So if you have WebSphere on Z or WebSphere Liberty on Z, our drivers can actually connect directly from those servers, as well as CICS. If you have the OSGI server support running, you can actually put our drivers in and run job applications from Kix to IMS database as well. And then obviously within IMS, you've got our IMS dependent regions, whether you're using message processing regions, IFP regions, BMPs, anything that's Java enableable, you can actually drop our drivers in and access IMS DB from Java as well there. So as far as how we ship our drivers, we've got, we basically ship one jar file, which is the IMS UDB.jar, and that basically gives you a mix or options of both the JDBC interface to access IMS data through SQL, as well as lower level DL1 for Java APIs that give you more of a DL1 abstraction for what you might be used to from a COBOL standpoint or PL1 standpoint. And those DLI APIs, if you're running off-platform, have database support, and if you're also running within IMS, it also has TM support for dealing with the message queues and stuff like that. So also, if you're running from a Java EE server, we ship 4 resource adapters. This is so you can deploy those in the server, create some connection factories, and be able to again, access our driver through the resource adapters. Typically, I've been pushing our customers to use the 2 resource adapters that deal with JDBC. There is a CCI or a common client interface that we support as well, but it's less popular, and I think most customers are more comfortable in the JDBC and DL1 area anyway, so that has really been our recommendation. All of these solutions I'm talking about are part of the base IMS install, so you can get access to them. It's not a paid feature. We ship that with FMID JMK XX06, where XX is the IMS release number, so 1506 is the latest there. All right, so that was a crash course for the Open Database solution. What I want to first start with is some of the ways that this works from a distributed standpoint. So we'll table the on-platform discussion and start with the distributed access. So basically, you have some application that uses the universal drivers, and that gets a connection through TCP/IP over to IMS Connect, and then IMS Connect and ODBM basically, and ODBM stands for Open Database Manager, work together as a DRDA server for basically taking requests from these clients and turning them into DL1 calls that ODBM issues against IMS. So you can kind of think from an on-platform standpoint, ODBM is really the DL1 application fetching data and then packaging that up to ship it back to the client and surface back to the Java, the end user in Java. So along those paths, basically, we're going to talk about several performance considerations. We're going to start in the application space with SQL and JDBC. We'll talk about the distributed server. So if you're running like in a WebSphere or WebSphere Liberty, you know, there's things to consider like thread pool settings or connection pool settings and timeouts and such. Similarly, in IMS Connect, it has a couple timeout values that you can set, and we can talk about how to set those appropriately. And then there's some ODBM routing options that are in IMS Connect as well. If you want to control, if you've got data sharing environments, if you want to control how things are routed between ODBMs and IMSs. Then from an ODBM tuning standpoint, we'll kind of hit on, you know, tuning the threads, maximum threads that it can open against your IMSs, and some, if you're using FastPath, there's FastPath buffer tuning, as well as some considerations around whether you want to set RRS yes or no. And then there's sizing your IMS and tuning those buffer pools. So these are kind of some of the topics we're going to hit along the way here. So the first one we'll talk about is distributed relational database architecture. And this is the architecture for which we created the protocol that we're going to be flowing over TCP/IP to and from the client in IMS Connect. And so this does everything from authentication, authorization, scheduling PSBs, issuing database requests, doing commits and rollbacks. And so what I'm going to do is actually take you through a DRDA flow example for from an application issuing a SQL request all the way through fetching data from the back end. And I find that this is helpful for customers getting started because either the sysprogs or DBAs need to understand how the data is being accessed, what implications that might have to IMS. So, and it also helps the application developers really understand how they're affecting the IMS system as they're writing these applications. So I think it brings the two sides together. So as I mentioned already, we have the DRDA trace. We have the ability to enable DRDA trace from the Universal Drivers, and that's really what I'm going to show in the next several slides is kind of captures of those logs so that we can see how those flows look. There are other tools like IMS Connect extensions or BMC Energizer, depending on which set of tools your shop is using, that also has the ability to capture these logs through IMS Connect. But here's kind of the mile-high view of everything, and don't worry, I'm going to zoom in as we go forward in these charts. But basically, we've got 4 components here, which is the IMS Connect, our Java clients, and we've got IMS Connect, ODBM, and IMS. And we're going to basically be showing from connection to termination of that connection what happens in a very basic application flow. Before we do that, I'll also note that when you're tracing using the universal driver logging, we also do log network time and server time. So if you have some questions on where you're losing time or where you're spending your time, you can actually see, network time is really the time that the client is writing and then writing the stream to IMS Connect. And then the server time is the amount of time we're waiting for a response from IMS Connect. So if you're suspecting, okay, maybe there's some database slowdowns, then you can kind of verify in these logs that the server time's a little bit higher than it should be. And maybe that's an indicator to go and look at the database calls you are issuing and seeing if you can tune those. But as I mentioned before, there's a couple tools that'll also help you capture this information as well on Z. All right, so now let's get into the actual flow. So if you're familiar with JDBC, you typically start with getting a connection, and after that you'll prepare a SQL statement or or execute a SQL statement. You'll process the result set, you'll commit, and you'll close the connection is the very basic flow of a JDBC application. And so that's the flow we're going to bring you through from a DRDA standpoint. So as the SQL application actually gets a connection, it's going to establish the socket connection, and obviously if there's SSL involved, it's doing all of that handshaking. But once that socket's established, the first thing we're going to do with IMS Connect is actually exchange server attributes, basically saying, here's the levels that I talk, and the server side IMS Connect says, here's the levels that I talk, so that the driver and the server kind of get on the same page with what protocols they can flow depending on what maintenance level both sides are. And then there's access security check, which is one of the security mechanisms. So from a tracing standpoint, here's kind of what those flows would look like. You're exchanging server attributes. So again, this is flowing across what your host name might be, what your icon and ODBM levels are. So icon, is levels 1, ODBM has 1 through 7 as far as its features that it can support. This IMS1 is really saying which ODBM alias we want to go against. It's not the IMS ID per se, but it's an alias for an IMS ID that we want to route to. And then each of these requests end up responding with a reply data or reply message, just with the server side of view of things. So it happens that the server is on the same level as the driver, so all these numbers match. Really, there's not going to be too much overhead in this from a performance standpoint, but it's just our establishing some basics when getting a connection. So I'll go to the next slide. So the next thing that happens as part of this handshake is authentication. So we need to be able to send our username, in this case OMVS ADM, with a password that's obviously going to be masked in the log. But basically, this is the way IMS Connect is going to get the information to authenticate a user through RACF or through SAF. So this is probably one of the first places you might say, okay, if you're having delays in security check, if you find that there's a gap in time between the security check and the security check reply, then you might want to look at maybe your RACF database has some tuning issues. We typically don't see this as being an issue, but just something to be aware of what's happening when we issue this request. All right, and so the next piece of the flow is actually allocating a PSB to IMS. So in order to issue database calls, we obviously need some sort of thread scheduled in IMS with a PSB that gives us access to the data. So what we do is the client encounters the first SQL statement that it wants to either execute or prepare. And for us to really understand that SQL statement, the first thing we have to do is actually go and collect metadata about that PSB and the databases that are behind that PSB, so that we can actually properly interpret the SQL statements and turn it into a DL1 request. But to do that, we typically will have the IMS catalog set up. And the IMS catalog basically houses all the information that is defined in the PSBs or DVDs. And so first we go off and, sorry, go. Yes.
I've got a question from you from Andre Schumann. He says, are any of the communication flows encrypted, i.e. between Java Client and IMS Connect?
So yeah, if you have SSL enabled, you can, then that's all encrypted. By default, if you're using plain TCP and no SSL, then it is clear text.
Okay, great, thanks.
Yep. But yeah, most customers are obviously using SSL. So by the time to kind of continue on that thought, by the time it comes to the Java client will still have it in clear text, so it can actually log the information. So from a Java client standpoint, obviously it's in the clear, but the communication layer on TCP is all encrypted. All right, so from the first thing we're going to do here is really allocate a PSB. And so I think in our example logs, we have a PSB called BMP255. And so what that does is it forwards the request over to IMS Connect. It makes a request to ODBM to turn around and schedule that PSB. So at that point, you've got, if you were to issue a display active region against IMS, this is where you're going to see, another thread or another region showing active. And if that is successfully scheduled, it's going to come back and tell us so. Otherwise, it'll give us some error code saying, okay, this is a serially scheduled PSB and there's already one scheduled, or various other reasons that scheduling could fail. And once we've got a PSB allocated, the next thing we're going to do is flow a get unique record call, which is basically a newer DL1 call that came out with the IMS catalog that basically says to return an XML document that describes that PSB or DVD information that's stored in the catalog. And what we do is then cache all that information in the Java client so that for any future requests to that PSB or those databases, we have that information in memory. So you incur a little bit of this GUR overhead the first time, as that JVM warms up and connects to unique PSBs or databases. And so we'll see what some of these flows look like now. So there's this allocate RDB, which is basically our allocate PSB request, again to BMP255 and routing to IS1, and then we get back our reply on that. So from a performance standpoint, if you're seeing delays in between these two flows, what that can typically indicate is something like maybe a pool space. If you're waiting for pool space on an allocate request, basically that can cause delays until some other PSB is deallocated and frees up enough space for this request to complete. So we've seen some time gaps in here because they needed to do some IMS tuning from a PSB pool or PSBW in order for that schedule to complete in a timely manner. So yeah, that's one of the key ones there is pool space. From a GUR standpoint, what we do is we issue an open query flow over that basically tells us which PCB we're going after. The DFS cat 00 is the PCB that's attached to every PSB when IMS catalog is enabled. And so we're saying against the IMS catalog, we want to issue a GUR call, and we're going to send over this SSA list for that GUR call, which basically says give us the header in the catalog database has a sequence number or sequence key that is made up of a resource name being PSB or DVD, and then the actual name of the PSB or DVD, in this case BMP255. And the reply would look something like this, where you get an open query reply message, and then the query data itself. And so you can kind of see the makings of some XML here. There's a ton of data that wouldn't fit on a slide, but basically it's everything describing what was in that original PSB. And similarly, we have follow-on GUR calls for the databases that you're accessing as well. And if those databases point to secondary indexes and such, then we also go and collect that information as well. So now that we're connected to IMS and have information about the resources that we're connected to, now we can actually kind of proceed to process the SQL statement. So if we have some sort of statement like select star from PCB01 dot segment 1, we can actually now use that metadata to make sense of that query. And I'll kind of show you some of how SQL is processing later. SQL is processed into DL1 routines later in the slides. But for now, I want to focus on how the flows go across. So again, we're going to issue another open query call, and we're going to be either issuing a routine in ODBM of either a get unique loop or get unique followed by get next for that SSA until we get all the records back. And depending on your fetch size, if your fetch size is 1, then for every request over the network, we're going to return 1 record at a time. And then that followed by a continue query to get the next record and return that back. Obviously, that's not very efficient if you've got a lot of records to deal with. But what you would typically do is say, if you are expecting some unknown number of rows, but you expect there to be plenty, you're going to set your fetch size to 0, which kind of triggers ODBM to say, batch up as much as you can within, I think, a 1 meg area and return that back in one shot. And then as we exhaust and start processing that result set on the application side, once we hit, the next record that we need to go off and fetch again, we issue a continue query to go and get that next batch of records. So that helps prevent some network hops when you're fetching large amounts of data back and forth. And then eventually IMS, the DL1 call turns around and says, hey, I've got no more data for this query. So the get next call might return a GE or GB status code saying, this is the end, and we send back this end query RM to flag that to the client.
Okay.
So how that looks from sure.
I've got another question for you. This is from Prashant Kalal. He says, is a 1 meg a limit for fetch size?
So I think right now ODBM doesn't allow that to be tuned. So right now we haven't found a need to allow that to be changed, but there are ways to influence what the driver requests. So we do have a few tuning knobs, but we actually haven't had to touch that yet with customers.
Okay. All right. Yep. Thank you.
Sure. Yep. So yeah, for the open query request, again, it looks very similar to the one that we just looked at from a GOR standpoint. Instead, we're going against PCB01, and our DLI function that we're issuing is a retrieve NH. So typically for a SQL select call, it's either going to be retrieve or retrieve NH. And the only difference is the NH flavor flags us to do DL1 processing that does no holds. So basically, we either are issuing a get hold unique followed by get next loop, or we're issuing get unique followed by get next loop. So depending on how your SQL query is set up, if we know you're not going to do any updates against the data that you're selecting, then we use this no hold call to basically not end up issuing DL1 hold calls on the back end. So this would avoid get hold unique, instead just do get uniques. So that comes up often, is how are these SQL calls translated into DL1 calls? And again, I've got another chart on that later. But in this case, our SQL call basically resulted in this sort of SSA list. So hospital ward, where ward is less than 4 and greater than 10. And so that gets stuck down on the SSA list flow. And so this is how you can kind of tell from a DBA standpoint, if somebody says, hey, my SQL query is running bad, if you take a look at the SSA list portion of the flow, you can say, well, yeah, that is pretty inefficient query for this database, and you can kind of give them some feedback on that. And then basically, once the app does all the data collection and does its processing, it typically will end with some sort of commit or rollback call, and that's pretty straightforward from a DRDA standpoint. It's an RDB CMM for a commit, and you get a response of end UOW reply message for that commit. And if there's any kind of performance gaps here, then it might depend whether your ODBM is set up for RS yes or RS no, to try and figure out which kind of way to go to troubleshoot. If you're RS yes, then maybe something like RS archiving, was kicked off and had some delay for your commit to be processed. Whereas if you're using RS no, then you would maybe look towards IMS to see what the delay was for actually committing that work.
Kevin, more questions?
Sure.
I think must be the previous slide. Prashant has asked, on the left-hand side, send, buffer, etc. on the trace. Does active trace show those?
Yes, it does. So if you're looking at the universal driver traces, if you enable it from the Java client, this is exactly how it would look. If you're looking from IMS Connect extensions or BMC Energizer, they have different formats. And I don't think it says send buffer, so you have to look for different indicators. But from the universal drivers, this is exactly what you'll see.
Okay, so he carries on to say, in the trace, would I be able to see these calls from the IMS side?
No, so these calls pretty much are all captured in in the IMS Connect recorder trace or through IMS Connect extensions or BMC energizers, really where this information gets captured. But IMS has no idea that these requests are coming from a distributed client. Therefore, there's no notion from IMS trace that these are even being driven from DRDA.
Okay. Yeah. Okay. Well, another question though: how to set hold option in SQL?
Yeah. So that's going to come on a later slide, but I'll say it now anyway. We've got if you're issuing a SQL select and you know you're not doing any update, and if you mark it for concur read only, then we actually will flow retrieve NH in that case instead of retrieve. And also there's other cases where we can infer that you're not going to do an update, and in all of those cases we try to optimize you towards the retrieve NH path.
Okay, I think that's
so. If your fetch size is greater than 1, oh yeah, go ahead.
No, I was just going to say, I thought you'd finished. Sorry.
Oh no. So is there a follow-on question to that one, or did that answer?
No, that's it for the moment. Thank you.
Oh, all right, perfect. Good questions. All right, so I think we made it through commit, and really the end of the flow is deallocating that PSB. So it's just deallocate BMP255, and this flows across, and that PSB comes unscheduled at that point. And so if we go back to this view, we basically, at the end of commit, that's when the UR ends. At the end of deallocate, that's when the PSB is no longer scheduled. So if you issue display active region at that point, IMS will not show that that thread is active. And then lastly, your connection is pooled until you then close that connection. So if you're running in a web server like WebSphere or Liberty, and you've got this stuff set up in a connection pool, in those cases, you wouldn't have to reestablish these connections for each request or do these Exchange server attributes. Instead, we just pick right back up on allocating the PSB and issuing the next set of DL1 requests for the next request that came in for that application. All right, so that's kind of the crash course in DRDA. Any questions before I move on from the DRDA and start moving into the JDBC and SQL points? All right.
None on screen. So.
All right.
No.
Okay. Yeah. So from a SQL call standpoint, if you really want to see what your DL1 call procedure is going to be, we actually have 2 ways to do this. One is if you're using IMS Explorer for development, which is an Eclipse-based tool, it allows you to actually, there's a feature there that lets you punch in a SQL query and have it get translated to DL1. Another option there is when you get a JDBC connection in an application, you can actually call connection.nativeSQL and pass the SQL statement to that. And the output of that is actually going to be this DL1 procedure string. So it's really just describing how we're going to translate this SQL statement. And so I'll take a quick second to break down what we're doing here. So in this case, we're saying select all columns from hospital and ward, which are 2 segments in this database, where the hospital code equals some value. And so what we do is, because you want everything from both of these segments, the first thing we have to do is actually put in a command code D on hospital in order to get back both the IO area for hospital and the IO area for ward. And then the where, is telling us go and actually do some qualifications on that particular segment, in this case, hospital and host code. Now, what we don't get from this is the insight whether we're update or not. So if you actually prepared this statement using concur read only, as it says in the last bullet of the slide, that helps to direct us to avoid the hold calls, in which case that procedure would change to remove the hold. Similarly, if your fetch size is greater than 1, then we know it can't be an update call, because we require fetch size to be 1 in order to do updates, because we actually have to hold the record, return it back to you, you make some modifications, and then you turn around and say update row, which drives a replace request in deal 1. And so we can do some other inferences to determine whether we should hold or not, but we try to avoid the hold as many times as we can. And the other keys here to SQL processing, like with any other SQL database or relational databases, you got to key as much as possible. And from an IMS standpoint, if you can key all the way up to the root, you're going to be avoiding scans. So obviously, do that from a performance standpoint as much as possible. But obviously, it depends on what your application needs are. So we do also mention fetch size here. So if your select query is designed to return a fixed number of results, you're going to want to set the fetch size and the max rows to that fixed number, so that we don't actually do any extraneous get next requests, because there are get next requests that result in scanning the rest of the database when you know very well that it's not going to return any more data. And so we found that that's helped in certain cases. Typically, I would say avoid trying to fine tune to this level in the application, because it makes it a little bit more overly complex. So if you can stick to rules of keying your queries, that's best, number one. But if you really need to control things from a fetch perspective, then fetch size max rows is an option. And we also support the syntax on SQL queries that say fetch first 10 rows only, and that basically internally sets our max rows to 10, so that we don't ask for more than that from an IMS standpoint.
Kevin, another question for you.
Yeah.
Going back, I think it's Prashant has asked, how do I know from IMS a specific SQL took time CPU perspective?
So I don't think you're going to get, we don't have a way to trace back the SQL CPU time in IMS. I think we just have it from the PSB standpoint, when you scheduled that PSB to when you allocated that PSB. So your 07 and 08 records are going to say the whole unit of work, but not more granular than that. From an IMS standpoint, all you're aware of is the actual DL1 calls being issued, because actually SQL doesn't flow beyond the JDB, the universal drivers. The universal drivers translates to a DL1 routine, and ODBM and everything running on the mainframe only knows about the DL1 at that point, the DL1 calls.
Right, so, okay, got you, thanks.
Okay, perfect. And then kind of the opposite, going back to the fetch size here, the opposite of that is if you need your SQL to return more than one record, but you're unsure of the total number of records, then just set your fetch size to 0 and let us, batch up as much as possible to limit that network traffic. And I've already hit the point on the concur read only. So the next component we'll move to is IMS Connect. And so there's a couple considerations when setting up your IMS Connect. One is ODBM routing. If you've got a data sharing environment where you've got 4 IMSs with 4 ODBMs in front of each of those, or an ODBM in front of each of those 4 IMSs and an IMS Connect in front of each of those 4 ODBMs, you may want to control how requests are routed. IMS Connect, by default, if you're using a generic alias, it will round robin to all of those systems. But we found in certain systems, to reduce some complexity, we say if it comes into IMS Connect 1, then only send those requests to ODBM 2 or ODBM 1 if it's available. And if it's down, then route to some of the other ODBMs and IMSs. And that's actually helped to reduce some complexity in the event that you need to do some analysis and debugging on why certain things happened. So you know if it entered LPAR1 that everything is being processed on LPAR1. And you can control that through some of the IMS Connect routing exits. And I think, again, tools like BMC and IMS Connect extensions, BMC Energizer and IMS Connect extensions, both have ways to help you control that routing if you don't want the default round robin capability. Timeouts is another big one. There's two timeouts in IMS Connect. One is the port timeout and one is the ODBM timeout. The port timeout says after a client has allocated a PSB, every request, if it doesn't make a request after allocation or after a DL1 call for a certain period of time, we're going to time out that connection and close off the PSB so that we're not holding resources on the IMS side for too long. These timers are in hundredths of a millisecond or hundredths of seconds. So 6,000 would be equal to a minute. We typically tell people start with a minute on both of these and then tune from there. But we've had people that didn't understand what the values were and made it really small and saw these, in doing unit testing or some prototyping, they kept getting timeouts, and it was really because they were just set way too small. But conversely, you don't want to set them huge because ultimately you don't want somebody holding a lock forever that has gone off and disappeared or is not going to come back in a reasonable amount of time. The ODBM timeout, on the other hand, is kind of the opposite. It's when ODBM, when IMS Connect sends the request to ODBM to actually go and issue the DL1 calls. If IMS is taking too long, maybe because it's scanning or because there's a lock from some other thread, the ODBM timeout may fire and tell the client, hey, we've timed out because ODBM or IMS took too long to respond. So these are just ways of kind of controlling how much time we're letting clients take in IMS and how much time they're holding resources. At the moment, what these timeouts will result in, if there's work that's in flight, they'll result in us deallocating the PSB and rolling back the work. But that rollback at the moment is in the form of it will issue a user 210 admin. So this is another case where we get a lot of questions from customers like, why am I getting all these user 210s? And for poorly behaving clients, client applications, you typically do get a lot of 210 admins. And so those are usually signs that something's not working quite right. Now, we are currently working on an enhancement that basically will silence the user 210. So we won't issue the 210s, we'll internally roll back, but we'll start issuing some more informative messages in the ODBM as an ODBM message to tell you, hey, we actually got an internal deallocate request because of a port timeout or because of an ODBM timeout or because the client disappeared. So that actually will help some of these situations and understanding exactly why and exactly who made the requests that took too long. All right, so moving on to a couple of the ODBM considerations. We've got max threads. This helps throttle the amount of work that ODBM can schedule into IMS. And so if you set that to 100, then you can schedule no more than 100 PSBs at any given time to IMS, and any requests beyond that queue up in ODBM. If you happen to use FastPath, there are FastPath buffer and overflow settings in ODBM to be aware of. And then the other one from a performance standpoint really is RRS. If you need two-phase commit, or if you may need it down the road, then RRS yes is really your only option, because that's what we require to support global or two-phase commit transactions. But if you know you're never going to use that, then RRS no, setting that to RRS no can actually have less overhead overall. It's not a significant difference, but again, if you're never going to use global transactions, then RRS no will be a bit less. From an IMS standpoint, we kind of hit on it earlier, making sure your pool sizes are tuned to handle the new expected workload that might be coming in through this ODBM path, Open Database path. Similarly, your max PSTs may need some consideration if they're currently, finely tuned for all your dependent regions, but now you're going to have these new schedules coming in. You might also have to up your max PST values. And then the last really consideration is when you create PSBs for these new Java clients, a lot of times they'll start with read-only applications. And from a PSB standpoint, you want to make sure your PCBs are set with the appropriate processing options or proc ops that your applications are expecting to need. So if you need read-only to your data, or if they can tolerate dirty reads, obviously you want to set G or GO on your processing options to help reduce locks and contention if you don't need the ability to do updates. And then from a Java EE server, and I think this is the last slide on the distributed topic, distributed data access, it's really making sure that timeouts in your Java EE server agree with the timeouts that you have set in IMS Connect. So your connection pools timeouts should be agreeing with your port timeouts, for instance. And similarly, there's thread pools that basically limit and help throttle the number of concurrent connections or PSBs that can be allocated on the back end. So if you limit those pools or limit the connection pools and have those match or be less than the size of your max threads in ODBM, that can also help things from getting over allocated or overused on the back end. All right, so I do have, another set of slides here. So Trevor, I'll leave it to you time-wise. I know we're getting close to the 50-minute mark, whether we should go through the Java ONZ or if we should skip ahead a little bit to some of the summary.
Well, you've got 10 minutes, so well, just
right.
leave it if you want to. So do as much as you can.
All right, perfect. So we already talked about some at the beginning about the ability for these universal drivers to actually run on the platform in Z from various dependent regions. And so how that looks is, if you're running a pure Java application, you can look at the right-hand side of this where you would be running in a message processing region, which is kind of the Java equivalent of an MPP, or a JBP, which is more equivalent to a BMP. These basically are Java first applications that let you get control and then start using the IMS Universal Drivers to issue DL1 or JDBC requests, or even use the DB2's JCC drivers to access DB2 in the same application. And there are also options to then interface with COBOL from Java as well, or vice versa. If you're running in an MPP and extending a COBOL application, you can actually add calls that drive Java requests. So you can do Java COBOL interoperability or Java PL1 interoperability. We've got some customers really aggressively going the route of extending their COBOL assets using Java. And so that's really this next section that we're going to talk about. But the good news is there's not a whole lot of differences in some of these areas with how with the performance considerations. So from an application standpoint, we've got really the same as distributed. The same rules apply. We still optimize the same way. We do a lot of the pre-processing the same way when we interpret the SQL statements into the DLI routines. The only difference is we're not going through TCP to issue these requests where we're dropping directly down into one of the TDLI interfaces to actually issue the calls directly to IMS. One key thing for if you are going to do Java and COBOL interoperability is really minimizing the transitions between COBOL and Java. Anytime you transition, there's some expense. So you want to make sure that if you're going to Java to do some processing, you want to make it worth the trip. And same thing when you're going flip into COBOL. So the more processing you can put in Java, there's obviously benefits, because on Z that Java becomes zip offloadable, and if you stay over in that period, in that space for a longer period of time doing heavier lifting, then obviously that's going to help your general CPU consumption be reduced. When you're doing JNI work, you actually have to look up Java method IDs and fields to actually make calls from COBOL to Java. And so what we found is caching these lookups is key. There's some articles and things we've got on this. So if this is an area of interest, you can follow up with me and we can talk about this further. But basically, the more you can cache, the more you can build out some of your JNI helper routines to do that, the better off you'll be. We've also found that the way you're passing parameters between COBOL and Java can actually have a pretty significant impact. If you pass 100 like integers, through a method, that'll be less performant than actually creating, a 400 byte IO area using a direct byte buffer and passing integers in that IO area down to your other layer. So there's some optimization you can do from just parameter passing between languages as well. So the other thing, there's a couple Java checks that you can enable when you're doing kind of unit testing and debugging, which is check JNI option, and there's also verbose JNI, which can actually show if you're leaking Java native interface references. And so we've actually found this particular situation with a customer where they had an application where they didn't realize they weren't freeing some resources. So while the memory really didn't increase, what was happening is the queue of references kept growing and growing and growing. And so really what this meant is the green represents pause time. So as Java is doing garbage collection, pause times were taking longer and longer. And once we cleaned that up, this flattened out completely, and the application was behaving normally. So again, you can use DB, because you're running an IMS, you can actually access IMS database as well as DB2 database and mix the JDBC driver for DB2 as well as IMSs together. There are some DB2 specific recommendations, like limited block fetch that helps kind of increase performance for fetching large amounts of data. So you can use tools like Omegamon for JVM on ZOS or IBM Health Center to take a look at your Java heap and native memory to see if there's any leaks or how that's working out. You can also do method profiling to understand the overhead of your application and where you could maybe optimize and tune a bit, where you might get the biggest bang for the buck there. You can visualize garbage collection, locking, and thread activity. So these tools can be very helpful in doing that. And then because running with COBOL and Java interoperability requires LE to be enabled in your regions, you can also take advantage of some of the LE tuning options that they have available, and basically tune your heap pools in LE as well. All right, so we do have some performance at the lab. We actually have run distributed workloads up to 9,000, a little over 8,000 transactions per second. So these definitely scale. This was on a Z13. Actually, since creating these slides, we came out with a Z14 white paper as well that has a repeat of these measurements. note that as of version 13 and higher, some of the DRDA processing that we talked about today is zip eligible in IMS Connect and ODBM. So if those are options to turn on in both of those address spaces. So, if you are using or planning to use, that's probably something you want to look at to see if you can get some zip zip capability in your workload there. And this is an example of how much can be offloaded. So if your DRDA workload is set up with RRS yes or no, some of our measurements got up to 15 or 22% fewer MIPS on GP than they did before without this zip enabled. So so yeah, that's another good tuning option. For running Java in IMS dependent regions, I often get the question of, what's the overhead compared with COBOL? And so we actually have two lines here, a COBOL application running, the red line is a COBOL application running in an MPP, the green line is that same application running IFPs, and a similarly ported application written in Java. And with the blue line. And so what this is showing is there is overhead. There's about 2 to 2.5% or 2 to 2.5 times overhead to actually running Java versus COBOL in this comparison. But a lot of that processing is zip offloadable. So so there are trade-offs there. You get more skills because Java, you get to use more open source libraries or more extendable libraries. So hopefully you don't have to write as much code in Java. But there is some processing overhead in doing so. So definitely some considerations. Response times were very similar in those cases. And scalability itself was also very similar. So in terms of the max throughput, they were pretty comparable. We did the same workload running on Z13 and Z14, running Java dependent regions, and both of them hit well over 20,000 transactions per second. So pretty nice. Z14 actually got closer to 27,000 transactions per second with this workload. So definitely able to scale and handle load. And I'll close out with this. We've got two programs, one called Makerspace. It's a free offering. So if you are looking to do look into Open Database or running Java on Z in IMS, or do anything around DevOps or API enablement, we have this Makerspace program, which basically allows us to send out some experts or have calls with you remotely, actually go over some of the pain points and what problems you're trying to solve, and see what we can do about putting together a POC or a prototype for you to actually get your feet wet with Open Database or running Java on Z. So if any of you customers are interested in looking into this with us, reach out to me, and we can set up some calls to just go over what you would like to accomplish and look into. And again, it's usually just what we do is send out somebody on the technical side, somebody on our offering management team and design team to actually lead through like a 1 to 2 day workshop on how we can help solve some problems for you in these areas. So with that, I think I'm going to pass it back to Trevor. Hopefully that was helpful to everybody, and see if there's any more questions.
Okay, yeah, no, thanks. That was great. I've got one question from Karen Tisher, who asks, what's a Z13 and Z14?
So we pretty much had a maxed out one. I don't know the exact model off the top of my head. I can get that. And actually, maybe I'll shoot you our 2 new performance papers that we released. And I don't know if you have a good way of getting that out to everybody.
Well, I can put it on the website, and people can.
All right, perfect.
Yeah. So yes. So Karen's just said processors ? Yeah, Z13 and Z14 are processors.
Yep.
Okay. Let's see if we got any other questions coming up. Let's give people a minute to see if they've anything they want to put in. Okay, we're just looking at the time, but we'll start to move on. If any more questions arrive, I'll pick them up and give them to you. Let me just take back control.
Okay.
Let's make presenter. Share my screen. Brilliant. Yeah, no, so thank you very much, Kevin. That really was brilliant. So as we're a virtual user group, can you assume that we're giving you a virtual round of applause?
Much appreciated.
Yeah.
Thanks for having me.
Yeah, Karen's saying, thanks, Kevin. Excellent presentation. So, yeah, all good. Okay, just a few things quickly to run over. News. Well, I haven't got any IMS news, although obviously don't forget that IMS itself updates each quarter. Oh, quick question coming in. I know more people saying thank you and great presentation. I don't know if you can see that on your screen, but
no, but thank you. Yeah.
Okay. Yes. Yeah. Let's move on to articles. There's been a few IMS transaction tracking data insights. We've got you connected, which is by Sandy Sherrill, and that's on the Z Systems Developer Community site. Then we've got strengthening security for your IMS databases with RACF past tickets, and that's by Emily Sue, and that's in the same place. And a simple way to enhance IMS database dynamic segment layouts by Carlos Alvarado, and again all on the same website. And lastly, is your IMS restart taking too long by Standy Stoob? So if you're interested in any of those articles, there's links to them from our website, or you can find them on the Z Systems Developer Community site. Okay, can I ask for feedback about this meeting? You can use the comments page, or you can email me directly at trevoriteched.com. So coming soon, 9th of April, then put that date in your diary. We've got Scott Quillisi, who's principal at SQ Data Core, and he's talking about streaming IMS to Kafka, and he'll be looking at performance and tuning. And then the meeting after that is on the 11th of June, when we'll be discussing enhancements to IMS Connect extensions version 3.1. I put presenter Tracy Dean. She's actually facilitating getting us a presenter. Okay, can I remind you that you can keep up to date with what's happening in the world of IMS and on the Virtual IMS User Group website by following us on Facebook and Twitter. You can also join the Virtual IMS group on LinkedIn, and the URLs are all on our home screen. Remember that everyone likes likes, so you can go to our Facebook page and like us. That would be good. And if you're a tweeter or anything else, the hashtag is hashtag Virtual IMS. Oh, and lastly, I just wanted to mention the 2019 edition of the Arcati Mainframe Yearbook, which I know some of you completed the survey for. It's now available, and it's free and full of useful information for mainframers. So you can download a copy from arcati.com/New Yearbook 19. Oops, what's this? Right. Okay. That's all for this meeting of the Virtual IMS User Group. Can I thank you all for attending? I must thank Fundy Software, who have now been taken over by Rocket, who sponsor this user group. And I particularly want to thank Kevin Height for his brilliant presentation today. So that's it. Thank you all very much for joining the meeting, and I look forward to seeing you next time on the 9th of April. So thank you all very much, and goodbye.